Good evening everyone. My name is Uma Maheshwari. We are going to discuss about the topic of instruction set of 8085. In the previous video we have seen 8085 architecture and 8086 architecture and the difference between the same. Here we'll just see the depth concept of 8085, that is the instruction set. In this instruction set of 8085 we have branching instruction. In that branching instruction alter the normal sequential flow. These instruction alter either unconditionally or conditionally. Here the instruction set of 8085 is, that is a jump opcode is there, that is the opcode is JMP. Say for example we'll take this, the operand is, it is a 16-bit address, and the description of this opcode is jump unconditionally. JMP is for jump. The program sequence is transferred to the memory location which is been specified by the 16-bit address given in the operand. Here say for example JMP jump 2034H. Here JX, here it is a 16-bit address jump conditionally. The program sequence is transferred to the memory location which is specified by the 16-bit address given in the operand based on the specified flag of the PSW. Here the example is JZ, that is jump conditionally 2034H. Here the instruction set of 8085 is JC, that is jump if there is a carry. JNC is for jump if there is no carry. JP is jump if it is a positive number. Jump if it is minus, the opcode is J and JM. JZ is for jump if it is 0. JNZ is jump if it is not 0. JPE is jump if it is parity even. JPO is jump if parity odd. The status flag for this one is, it is being shown in this table. CY is equal to 1 means, like if there is a carry means the carry flag set, that is CY is equal to 1 means JC if jump if carry. If jump if there is no carry means CY is equal to 0. Jump if it is positive means S is equal to 0, and if it is minus means it will enable as 1, and so on. Here we will see the next instruction set is called, the operand is 16-bit address. The description of this one is call unconditionally. The program sequence is transferred to the memory location specified by the 16-bit address given in the operand. Before the transfer, the address of the next instruction after the call, the contents of the program counter is pushed on to the stack. Here the example is call 2034H. Here the opcode description and then status flag for this one is, CC is for call if there is a carry, CY is equal to 1. CNC is call if there is no carry, CF is CY is equal to 0. That means that if it is, there is no carry. CP is equal to, if there is a positive means the call if there is a positive case, S is equal to 0. And CM is equal to call if it is minus. CZ is call if it is 0 and if it is not 0. And CP is call if there is an even parity, P is equal to 1. If there is an odd parity means P equal to 0. Here the opcode is RC, written if there is a carry, CY is equal to 1. Written if there is a no carry means CY is equal to 0. Written if positive, if it is minus RM, and if it is 0 means RZ, if there is no 0 means RNZ. RPE is written if even parity, written if odd parity, RP 0. So the corresponding status flag is also mentioned in this table. The next one is this control instruction, control the operation of the microprocessor, which is being controls the everything, that is they controls the control of the operation of microprocessor. No operation is performed. For this case, the instruction is fetched and decoded, but if there is no operation is executed, example NOP, the opcode is NOP, operand is, that is none. The description is there is no operation, it is being done. RIM and SIM is like from interrupt masked if bit is equal to 1 means from D0 to D2, Interrupt enable flip-flop is set means if it is IE, that is interrupt enable, and I5 and then 6, 7 and SID is serial input data bit. And the next one is serial output data. Thank you. Here in this case we have seen the instruction set and also the instruction set of the call and then no operations and all. Thank you.